Alright, for this video we're going to be looking at the same setup of the magnet with the spinning coil in the middle, but instead of connecting it to the LEDs from the previous video, we're going to be connecting it to our power supply. You'll notice that the two leads have banana plugs connected to both of our commutators so that it can pump a current through this coil of wire. I'm going to turn this thing on. I'm going to pump about 7 volts, looks like about 1 amp of current is traveling through this coil right now. And so if you remember from the magnetic field lab, because we have a current going through this coil, it is basically turning into its own little permanent magnet. And in fact, you guys can't feel this right now, but it's very much sucked into this very specific orientation. So if this is the north magnet and this is the south magnet, what that means for us is that this side of the coil has got to be the south side of the coil, and it doesn't want to be in any other orientation. If I try to move it, it's going to just get sucked into the same position constantly. So that's cool, but not terribly useful if we're going to try to turn this thing into a motor. What I want to do is I want to get this thing spinning somewhat indefinitely. And well, the way that we're going to do that is by cutting it off at the very correct moment. I'm going to stick a piece of tape on what is the north side of the magnet so we can see it readily. Here, I'll put it right here. So this side of the magnet is the north side of the magnet, and it wants to be in this position at all times. It does not want to go anywhere else. But again, we want this thing to freely rotate. So let's say that we're going to have it spin in this direction. Watch, it's going to go this way, which I guess would be clockwise. So in that case, when the magnet is here, we want the coils to turn on. So it'll get sucked into the other side so that the north is facing the south. So in this case, we want the coil to be on, and then we want it to be able to turn off at this very moment. Because at this moment, if it travels past this point, like this, it's going to just want to get sucked back into that same location. So again, we want to turn the coils off at that very moment so that its momentum will carry it forward through to this half of the turn. And then it'll turn back on here and it gets sucked in again, turned off again, and carry through on its own momentum, and then on again. So what that means is that I'm going to use a little bit of tape here to turn off the magnet at a very specific spot. What I'm going to do is I'm going to stick a tape on this commutator, starting at this very moment. Let's put it right here. And I'm going to wrap it about halfway around the coil like this. So that now, as the magnet goes past this spot, the coil is turned off. And then the second it travels right around to about this spot, the coil will turn back on again and get sucked in. You guys can't feel that. That was awesome. You can feel the magnet turning on and just kicking and grabbing this way. So let me see what happens here when I give it a spin. Let's get it started. Okay, something's up. It's on here. So maybe I did a little too much. Okay, and by the way, I'm going to leave this in so that you guys can see the kind of troubleshooting that you might have to go through when you're doing your own motors at home. Alright, so I want it to be on right now and off here. So let's turn it off right about here. Sorry, no, it's a little further. Maybe I'll take a little bit less tape. Now for you guys at home, it's going to be a matter of where do you sand your wire. But for me, it's just a matter of how much tape, because I want to have it off at some points and on at some points. So it's going to turn on right about there. That looks good, actually. Let's try it now. Oh, come on. Give it to me. I'm doing it. Right, here we go. Go, motor, go. Oh, we got something. There it is. And this is what it's like to troubleshoot a motor. You need to have it on at certain times and off at other times. I'm going to give it just a little bit current too here so you can see it really doing its thing. There we go. And that is a motor. So for question number 8, why is this considered a motor? What about it makes it a motor? Okay, I'll catch you in the next video.